Hey guys, I just wanted to make this short video to go over a short explanation of my beta calculation code. In the first video, I went over how to properly download it and run the program, but I didn't really get kind of behind the scenes into the hard code itself to understand where it's getting the data and so on. And I feel like if people are going to be using this in their projects or to do their valuation models, whatever it may be, I feel like it's good to have a proper understanding of what the code's actually doing rather than just having a black box where you input numbers and you get an output. So opening up the code here, we're just going to start at the top where you see all these purple text and all these kind of modules up top. And what these 9 lines are is basically we're importing the same modules that we did in the first video when we used pip install. Although we use pip install, we still have to import them in the hard code itself. And that's basically what lines 4 to 13 do. But then after that, we hop into the actual code itself. I'm going to be kind of highlighting lines as I talk about them. But the first things we need to do, which consists of kind of all this code here that's highlighted, is we need to define 5 variables. The first one is ticker, which is pretty obvious. It asks you to input a company's ticker, and it saves that as a variable called ticker. The next is we have a variable called custom, and this is where you input if you want to do a custom calculation or standard. And whatever your input is, it then hops into a if statement, which is right here. And what it does is it checks what the value of custom is. So if custom equals custom, so if the user enters custom, then it prompts the user to enter 3 more inputs for the period input, interval input, and beta cutoff, kind of whatever the user wants them to be. But if custom equals standard, then it sets beta cutoff, period input, and interval input to the set limits that I set for the standard calculation. And then if anything else is entered besides custom or standard, the code will tell you to please enter custom or standard, since those are the only 2 inputs that would actually move you further into the code. After that, once we have our 5 variables defined, we can hop into the actual calculation itself for the beta. So the first thing we do is we create another variable called symbols, which is right here. And it basically makes a list of our ticker as well as SPY. And then after that, we go down here to data. And what we have to do is we have to download the data for our ticker as well as SPY. So what this YF function does is it downloads the data for our symbols, which is our list for our ticker and SPY, straight from Yahoo Finance. It uses the period from our period input, as you can see highlighted here. And for interval, it takes the interval input that is also input above. And it takes the adjusted close price for our ticker and the SPY. And then after that, we have to change it to a percent change rather than actual values. So what we do here is price change equal data percent, and it creates the percent change weekly, monthly, or quarterly, kind of whatever your interval is. After that, you can hop down here to where it says DF. And this first line here, where it says price change drop, is basically the first row of the data we have to cut off because there is no percent change. To calculate percent change, you need the current value and the past value. And since there is no past value for the first value within the row, we have to cut it off of the data. After that, we create another column within the data. So you can kind of think of this as an Excel spreadsheet. And right now we have column A, which is our ticker and has all of our adjusted close prices for our period and interval. And then we have column B, which has the SPY's adjusted close price for the period and interval. So here we're creating a third column, column C, and that column is titled PD, which stands for percent difference. And what it does is it takes the absolute value difference from our ticker's percent change, and the SPY for whatever the interval is that we inputted above. And then after that, you see this df drop function. And this drop function is dropping the kind of the beta cutoff that we added earlier within the code. So what it does is if the price or the percent difference column is greater than the beta cutoff, it cuts off that row of data from the calculation. So for example, if we take a 5-year weekly beta, with a cutoff of 10%, just like our standard is here. If our ticker either outperforms the SPY by 10% or underperforms the SPY by 10% for that week, it is considered an outlier and cuts off that data row, and it won't be considered within the regression. So that is what line 36 does. Line 38 and line 39 are pretty simple. They just assign the X and Y values. So we have for our X value, we have our SPY percentages, and our Y value, we have our tickers percentages. And line 40 is basically the whole program itself. It is the model. So it does a linear regression for our X and Y variables. And then we get a R2 score, which is equal for Y and X here. And then we just hop right into the print functions. So what we do here is, besides the copyright, under that we have beta and the model coefficient, which is the company's beta from the linear regression we did here in line 40. Line 47, for DF intercept, we actually create a intercept within the regression, because on Python, when you're using the stats modules, the regressions don't have an intercept built in, so you have to add one yourself. So here we are adding an intercept into the model, and then we print mod2 summary. So this mod2 here, as you can see from line 47 to line 49, prints a summary of that, and then finish up with another copyright. And then 53 to 58 is basically that pop-up you get after you kind of fill in your inputs. So it plots a figure, a scatter plot for X and Y. It adds the titles. So the title is data and then percent. X label is SPY and Y label is whatever your ticker is. So if we can go through and just run this code quickly, we can kind of see how all of that makes sense. So input a company's ticker, we can use teledoc, for example. So if you enter tdoc, press enter, now it's going to ask for the custom calculation or standard. So if we put in custom, it'll go through that if statement that I talked about, and it'll see that I entered custom. So now it's going to prompt me to enter these inputs here. So let's just say we want a 2-year beta, calculate it weekly, and we want an outlier cutoff at 12%. Click enter, and we get the pop-up, which, as I mentioned, is from the code 53 to 58. And we can close that. And then looking here, if I can scroll down a little bit. So we have our beta here, which is the model coefficient, as I printed here. And you can tell that that's correct if you scroll down to the, I'll expand this so it's easier to see. When you look at the regression results that are printed, you can see that if you go down to the model coefficient here for SPY, you can see that it is the same as the beta. So what we are basically doing here is taking this value straight from the regression results and just making it easier to read. And that's basically the whole code. It's fairly simple, kind of looking at it. And as I mentioned, you can probably read through this yourself and understand what's happening. But I just want to provide hopefully a clear understanding of what's happening, so that when you're using it, you're able to explain kind of how the program works and why it's reliable. But besides that, the code's pretty self-explanatory, pretty easy. And that's pretty much it. That's all I wanted to do for this video. Probably next week, I'm working on another project. It is a program that calculates a WACC with a very few inputs. I should have a video out for you guys in about a week with that, with the finished file and kind of a tutorial on how to run that program as well. But I hope these programs are going to be useful for you guys in your evaluations, in your kind of understanding, and in your classes as well. But I hope you guys have a great day, and I will see you guys in another video.